All right, guys, Dr. Kruse here. Let's find some maximum and minimum values. So let's pop this into our graphing calculator. So hit your y equals button, and you guys on the 83 like I'm using, you're going to have to add these red parentheses. So anytime we deal with a fraction on the 83, we got to put parentheses around the top and parentheses around the bottom. If you're using an 84, you can use your green F1, so alpha F1, and choose the first option. It'll put a picture of a fraction up there for you. But I'm just using the 83, so I'm going to add the parentheses here. All right, so here's what it looks like on the 83. So parentheses 3x parentheses divided by, all right, that puts us on the bottom, and parentheses 4 plus x squared parentheses. Now they said set your horizontal span from -6 to +6. They're talking about this window here from left to right. So from left to right, they want us to go from -6 over here over to +6 over here. And that's in your window. So press your window, and whatever it's set at, change it to what they said. You want your low x, your x minimum, to be -6. And you want your high x, your x maximum, to be +6. Now from there, I just hit zoom fit. So I'm going to press my zoom key. And if you scroll down to 0, or you can just press 0, I'm going to choose zoom fit, and it should give me a nice picture. All right, so here's the graph we're going to deal with. Here's my minimum. That's at the bottom of the valley there. And then if I climb to the top of the mountain over here, that's going to be my maximum. So we're going to calculate a minimum value and a maximum value. All right, so I'm going to start with the maximum, the top of the peak here, the top of the mountain. First thing you do is do calculate. So that's above your trace button right there. Pull up calculate. And we want to calculate the top of the mountain. So we want the maximum. And it's asking us to set some boundaries. It wants us to set some fences. So we're going to set a fence on the left side of the mountain, and then we're going to move over to the right side of the mountain and set another fence, and it's going to look in between those two fences, and it's going to find that mountaintop, that maximum. So it's asking me for a left boundary. I'm going to locate my cursor, and I like to start out by just kind of standing on top of the mountain there. All right, and since it's asking for a left boundary, I'm going to take 5 or 10 or 15 steps to the left until I'm clearly to the left of the peak. Here's the peak, and I'm on the left side of it. I'm going to press enter to set that left boundary. And it puts a little triangle right there. You can't see it very well. Let me move out of the way. It puts a little triangle here on the 83 where it sets the fence. On the 84s, some of those 84s, it'll draw the fence for you. So you'll see a dashed line, vertical dashed line. All right, I'm going to move back to the top of the peak. And now it wants me to set a right boundary. So I need to go to the right 5 or 10 or 15 steps. Just make sure that you're clearly on the right side of the peak and press enter. And there's my two fences. There's my left boundary and there's my right boundary. As soon as I press enter again, it's going to look in between there and find the high point. It's going to find the max. It's asking me to guess. I never guess. I just press enter a third time. And it's thinking over there, and it says your maximum is 1.999999. We're going to call that 2. Your maximum is 2 steps to the right, and that's 0.75. That's about 3/4 of a step. So 2 steps to the right and 3/4 of a step up. So 2 steps to the right and 3/4, not even a whole step up, is the address of our maximum. Now what are they asking for? Well, it depends. If they say, when did you get to the top? They're asking for the x number. They're asking for the 2. Anytime they say when, they're asking what was the x coordinate. So after, let's say after 2 minutes, I was at the top of the roller coaster. And maybe they say, well, how high were you? And when they say how high were you, they're asking for the maximum value. That's the y value. So after 2 minutes, after 2 minutes went by, I was at the top of the roller coaster. How high was I? That's my y value. I was 0.75 feet or yards or miles or whatever up in the air. So the x value tells you when the peak happened, the max, and the y value tells you how high the max was. We're going to calculate the minimum the same way. So I'm back in the calculate menu. This time I'm going to choose minimum, and it wants me to calculate the bottom of that valley. Now these words are kind of in the way. So there's several ways to do this, but what I do is I just take my window and I move it down a little bit. So however far this window is going down right now, I need to make it go down a little bit further. So I'm going to press my window and make my y go down a little further. Here's my minimum y. Here's my low y. So right now it's going down below the x-axis about 0.75, about 3/4 of a step. I need it to go down a little bit further, all right, so that I can see what's going on, so I can get those words out of the way. So I'm going to make this a little bit lower than negative 0.75. How about -1? Whoops, that's not the right one. How about instead of negative 3/4 of a step down, let's go negative 1 whole step down. And I'm just going to press graph and take a look. That's getting pretty close. I need to move the window just a little bit further down. So I've moved it a full step down. Now I'm just going to move it 1.5 steps down. Back to window. And I move my window a full step down. I'm going to move it a little bit further. I'm going to move it 1.5 steps down and press graph. And you just kind of play with it until you kind of get a picture that you can work with without the words getting in the way. So when the words got in the way, all I did was just drop my window down a little bit further. Go into your window and change your y minimum to something a little bit lower so that you can see what's going on. Open your window and just move your y minimum down a bit. Just kind of experiment with it. All right, back to calculate. I want minimum, and now my words are not in the way. So I go stand in the bottom of the valley. All right, I stand in the minimum, and it's asking me for a left boundary. So I need to go left, left, left a bunch of times, 5 or 10 or 15 times, until I'm clearly left of the minimum. There's my left fence. Now it's asking for a right boundary. So I go stand in the bottom again and take 5 or 10 or 15 steps to the right. And whenever I'm sure that I am to the right, I'll set my right boundary, my right fence. So here's my left boundary, here's my right boundary. As soon as I press enter again, it's going to look in between there, and it's going to find the address of that minimum. All right, it's thinking up here, and it says negative 1.999998. That's 2. Let's call that negative 2. So negative 2 and negative 0.75. So the address of this minimum is 2 steps to the left, negative 2, 2 steps to the left, and 3/4 of a step down, and 3/4 of a step down. If they ask you when did you have a minimum, that's at negative 2. If they ask you what the minimum value was, they're asking how low did it go, it's negative 3/4 of a step down. All right, when is the x, how high or how low is the y? All right, here's the next one we're going to try. We're going to set the window from 0 to 5 for our x's. That's the horizontal span. So from left to right, they want 0 to 5 and then zoom fit. And we're going to find the minimum for this function right here. Now, you guys on the 83s, make sure you close this parentheses here, because when you hit root on the 83, it's going to open the parentheses and you're going to enter x. And then if you don't close it, it's going to put the +7 under the root, and we don't want that. We have to tell it when to stop rooting. You guys on the 84s, just make sure that when you're done with the root, that you take 1 step to the right to get out of your root, and then hit +7. Just make sure that this roof of the root, make sure that doesn't go over the 7. Make sure you step out of the root and then +7. So make sure the +7 is not under the root. All right, here's what it looks like on the 83. I had to close the parentheses after the x, so I'm telling it to stop rooting after the x, and that means the +7 is out here by itself. All right, so let's, whoops, not that. Let's set our window like they told us. Still haven't got it. There we go. We're going to set our window 0 to 5, so from 0 to 5 on the x's, and I'm just going to try to zoom fit and see how my picture looks. And if I don't like the looks of it, then I'll try something else. Okay, I want to find the minimum. All right, the minimum is right here. I'm going to run into that problem again where if I calculate the minimum, my words are kind of in the way. So, I mean, there's nothing stopping you from just going ahead and proceeding. You just move this cursor, even though it's going to be in the words, you just move this cursor way over here, so until you're sure that you're left of the valley, the minimum, and then you move your cursor way over here to the right until you're sure that you're to the right of the valley. It'd be helpful. I mean, it'd be nicer if we set the window and drop the Y down a bit, but you don't have to. We can just go ahead and proceed. So just follow your cursor there. You can kind of see it through the numbers. Just let it flash. There it is. I'm going to go a little further left. Okay, I'm sure that I'm left of the minimum, so I'm going to press enter, and I've set my fence right there. Now it wants a right boundary, so I'm going to go to the right, and I'm going to go pretty far because I want to make sure that I am well to the right of the minimum. See, it looks like I'm to the right, but I'm not totally sure yet, so I'm going to go a little further. Just want to make sure that I'm well to the right. I'm going to set it there. And there's my fence to the left and to the right of the minimum. It's going to look in between and find that minimum. So there's our minimum over here, 2.25 steps to the right and 4.75 steps up is the address of the minimum. Now it depends what they ask. If they ask you when did you have a minimum, that was after 2.25 years, for example. And if they ask you how low did it go, what's the lowest that got? They're asking for the Y value. They want to know how low did it go. It dropped all the way down from, say, 20 to 10 to 5 and dropped down to 4.75, and then it started going back up. But the lowest that it got was 4.75 steps up in the air. All right, now sometimes you can't exactly see the top of the mountain or the bottom of the valley. All right, if you can't see them, then we can't tell the calculator to calculate it. And sometimes we have to go to plan B and figure it out using our table. So if you can see it, if you can see the top of the mountain or the bottom of the valley, if you can see the max or see the min, then go ahead and calculate it. And if you can't see it, try using your table. So I'm putting in x cubed plus x. I'm going to set my window from 0 to 5 horizontally. So I'm going to set my x's from 0 to 5. I'm going to try zoom fit and see what happens. And if I have to adjust the window, I will. All right, so looks like if we move here, if we move to the right, it's going higher, 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 higher. This is my maximum right here. This is the highest that this picture got from x's from 0 to 1, 2, 3, 4, 5. From 0 to 5, the highest that this picture got was that point right there. Now I can't calculate that because that's not the top of a mountain. I can't set a left and a right boundary and have it look in between. So I got to go to plan B to find that maximum. And I'm going to go to my table and look at x's from 0 to 5 in my table. And I'm going to see which one has the highest y value. It looks like my 5 is going to have my highest y value. I better set up my table before I get started. I'm going to start at 0 and go up by 1s. And now I'll go over and look at my table. And remember, we're only looking at x's from 0 to 5. That's what they told us. We can only look at x's from 0 to 5. So don't look any further. Even though the table goes on, forever to infinity, don't look at any of those values. You're only looking at x's from 0 to 5. Now let's watch the y's. It started at 0, went up to 2, up to 10, up to 30, up to 68, and up to 130. So the tallest that this graph got was after 5 seconds or minutes or years. After 5 units of time, our graph grew to 130, and that is our maximum. So our maximum value is 130. The tallest that this graph got, if we just look at it from 0 to 5, the tallest that it got was 130 steps up in the air. When did that happen? After 5 units of time. After 5 seconds, after 5 years, after 5 minutes, whatever they're measuring. All right, let's go find this minimum value now. And again, I'm looking at this graph and I'm asking, okay, for the x's from 0 to 5, 0, 1, 2, 3, 4, 5, for the x's from 0 to 5, what's the lowest that this graph got? So I'm following it down, 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 lower, 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 lower. Looks like it's going to be in here somewhere, all right? We can't calculate it because this thing did not turn and go back up. If it had turned and gone back up, we could go into our calculate menu and calculate a minimum, but it didn't, all right? We're going to have to find this minimum in the table as well. So I go to my, I go to my table. Oh, I missed. Let's try that. I go to my table. Now I'm only looking at x's from 0 to 5. Here's the tallest that it got, and then it got shorter, 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 all the way down to 0. Now if I want to make double sure, I just kind of go into my table setup and I take smaller steps, like maybe steps of 0.01 or something like that. Take small steps, and I just want to make sure that there's not another, minimum hiding there. And it just continues to go down, 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 0.08, whoops, let me get over here, 0.07, 0.06, 0.05, it's dropping, 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 and we can't go past 0. Even though there's numbers up there, we can't go past 0. So the lowest it got was 0 steps high. So our minimum was actually the origin. When was it the lowest? At 0 seconds. What was the lowest it got? The lowest it got was the x-axis, which is 0 steps high. All right, this will be the last one. So your instructions say include values of n up to 350. That's another way of saying set your window from 0 to 350. I want to go up to 350, starting at 0. So we're going to set our x as 0 to 350. We're going to put this into our calculator. Again, if you're using the 83s, you need the extra set of red parentheses. And let's find this maximum value, all right? I want you to try and find the maximum value of 10.36. And I want you to calculate the zeros. The zeros, we used to call them x-intercepts in junior high. I want you to show me where the graph hits the x-axis. So we're looking for 0, 0, and 228, 0. And I'll show you how to calculate those. All right, so here's what it looks like in the 83 with all the extra parentheses. And I want to set my window from 0 to 350 because that's what they asked us to do. And I'm just going to do zoom fit and see what happens. See if my picture's nice or if I need to adjust it. All right, so this is a picture of this curve here, and it's going from x equals 0 all the way out to x equals 350. So maybe we're watching this thing as 350 minutes go by or something like that. And this thing grows, 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 reaches a max, and then it drops, 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 and it actually drops down into the negatives. All right, so there's 3 things I want you to calculate. I want you to calculate the max, and then I want you to find this x-intercept, and I want you to find that x-intercept, which we're going to call a 0. Let's calculate the max first. So calculate maximum. I want to, now the words are in the way, but we're just going to fake it. All right, I'm trying to set a left boundary. I could move the window up a little bit, but I'm just going to kind of watch my cursor and make sure that I'm well to the left. Okay, I'm definitely left of the peak. And now it's asking for a right boundary. So I want to move until I'm well to the right and just kind of follow that cursor over. And I'm over there, that's well to the right of the peak. Got my 2 fences, and there's my maximum at 73.27 and 10.36. So if they ask when did you have maximum profits or something like that, well, when was after 73.27 months, or after I made 73.27 widgets or whatever your factory's making, I had a max profit. How high was the profit? It was 10.36 steps up in the air. Maybe it was $10.36 million profit. Okay, let's go calculate these zeros. I'm going to start with the easy one over here. That's called a 0, where it crosses the x-axis. And you'll see why in a second. But I'm going to calculate a 0 which is an x-intercept. Now we calculate it the exact same way. We have to set a left boundary, so I'm going to stand on the 0. I'm going to take a few steps left and set a boundary, and then I'm going to take a few steps right and set a boundary. So I got to find my cursor. I'm kind of heading for the 0. I want to go stand on it. All right, takes a minute. Okay, so I'm standing roughly on the 0. They're asking for a left boundary, so I'm going to take 5 or 10 or 15 steps to the left and set that boundary. And now it's asking for a right boundary, so I'm going to go stand on it again. Standing on the 0, now I take 5 or 10 or 15 steps to the right, set that, hit enter one more time, and it looks in between there and it finds that spot right there. It says if you go 228 steps to the right and don't go up and don't go down, you'll be right on the x-axis. This is why we call it a 0, because it's not above the x-axis and it's not below the x-axis. It's sitting right on the x-axis, so we call it a 0. So your 0 is located 228 steps to the right. When did you have a 0? After 228 minutes or seconds or years or whatever they're measuring. Now the other one's not quite as easy because it's right over there on the y-axis. So there's a couple of ways to do it. I'm going to get over there a little closer. Okay, a couple of ways to do it. I need to set a left and right boundary, just like I did over here. I set a left boundary and a right boundary. I need to see both sides of it. So probably the easiest way to do this is to move your window a little further to the left. All right, so I'm looking at my x's, and they told us use x's from 0 to 350. We did that. But I need this 0, I need that to be a little bit further to the left. So I'm going to go to my window, and instead of 0, I'm going to take a few more steps to the left, like maybe over to -5 or something. And let's hit graph and see what that looks like. All right, well, that's a little bit of help, but it's not great. Let me see where I'm at again. Let me get over there closer. All right. That's not great. I'm going to go a little bit further. So window, and I'm going to go to, I don't know, -20 and take a look. Okay, that's a little better. All right. So here's our graph from 0 to 350, but I had to move the window a little bit to the left because I need to set a fence to the left and a fence to the right of this 0. So let's calculate that sucker, a 0. And I need to go stand on it, get my bearings. It'll take a minute. Moving kind of slow. All right, there we're getting closer. So I want to go stand on it and kind of get my bearings. Now it's asking for a left boundary, so I need to take 5 or 10 or 15 steps left, 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 and I better stop there because I'm going to go out of the window. So I am left of the 0. It looks like I went down, but I'm actually moving to the left. Now I'm going to go right, get back there. I'm standing on the 0. They're asking for a right boundary, so I need to take 5 or 10 or 15 steps right. That's probably far enough. I'm going to set that. And there I've set my two fences, my left and right boundaries. And I press it one more time. And it says, hey, you got a 0 at the origin, at 0, 0. All right. So that's how you calculate the top of the mountain. Set a left fence, right fence, and it gives you the address of the peak. The x value tells you when that peak happened. The y value tells you how high that peak was. All right, your zeros are where it crossed the x-axis. For example, in a business function, these would be called break-even points. And you just found the two break-even points for our profit function. You can find this in the table, but I showed you that just by adjusting the window a little bit, you can go ahead and calculate it just like we did this one by setting a left fence and a right fence and having the calculator find it.